What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 10, Section 3, Polar Coordinates. Let's do it. How do our polar coordinates differ from rectangular coordinates? So let's take an example here, and we're going to do a polar coordinate and then a rectangular coordinate. So here would be polar, and here's rectangular. So for polar, we have two values. We have an r value and then a theta value. For rectangular, we have x and y, our typical xy coordinate pair. So how does the polar work? And by the way, you can graph similar points or the same points really in two different ways. For example, we have our typical rectangular coordinate. Let's say we go 2 out and 3 up, right? So that could be a coordinate of like 2, 3, and that would be right here, right? This is how much we go to the left or right. This is how much we go up or down. Now with the polar coordinate, it's a little bit different, right? We got our x-axis right here, and starting at this point, right, we have a theta value. So let's say, for example, our theta is in radians. So let's say we have pi 6 for the theta, and then we have an r value of 4. So what that means is coming from this axis, we basically go up by pi 6 radians, which is the same as 30 degrees, by the way, so up here. And then we go a distance of 4 out on this line from the origin. So it'd be like 1, 2, 3, 4. And then you'd have a coordinate here of 4 pi 6. So anyways, that's the way that the two coordinates are different. Polar uses a length and an angle, whereas rectangular is two-dimensional, kind of like up, down, and also left, right. That's the difference. Done. So this one says explain how polar coordinates are graphed. So to do that, I put up a graph here in that sort of polar setup, right? And let's take an example here. Let's take an r value of 3 and then a theta value in radians of pi thirds, okay? And just so you remember, pi thirds is the same as 60 degrees. So that might be an easier visual if you're more familiar with degrees. But the bottom line is we start over here, right? We start kind of out here on the x-axis, and then we raise up based on that degree measure or that radian measure. So pi thirds or 60 degrees, this would be 30, this would be 60, this would be also pi thirds. So this is the angle that we're on. So there's the angle. And then the 3 means from the center, we step out 1, 2, 3. And then we'd plot the point right there, right? If I change this value to 7, we'd go 4, 5, 6, 7 and plot it there. But that's the general idea. You apply the angle, then apply the r value. That's how you do it. Done. Explain why the 2 points -3, pi halves and 3, negative pi halves are the same. All right, so I'm gonna graph both of them. So first, let's graph this one, -3 pi halves. So again, I'm gonna start with that theta value. So the theta value is pi halves. It's like the same as 90 degrees. So starting from this point, we go up to here. So here's our theta value. And then it says not +3, but -3. So then instead of going up 1, 2, 3, we go backwards. So we actually go backwards, but along the same lines, 1, 2, 3. So we're right here. And then for the second one, I'm going to do it in red. So now we're again starting here, and it says negative pi halves. So instead of going this direction, we're going to go clockwise. We're going to go the opposite way. So negative pi halves would land us here. Okay, that's again like negative 90 degrees. And then it says +3. So where that line is, we're going 3 in that direction. So we go 1, 2, 3. And look at that. It's the same coordinate. So that's why these two are the same. That's how you do it. Done. So for this one, we're converting the polar coordinates to rectangular. And the way that we're going to do that is by using this little infographic, right? And we're going from polar to rectangular. So what we're doing is we're figuring out what the corresponding x and y value are by saying that x is equal to r cosine theta and y is equal to r sine theta. And the r value is this first value, so that's 5 in this case. And the theta value is the second value, which is pi, so that goes here and here. So then we got 5 cosine pi, 5 sine pi. All right, now if we remember the unit circle, okay, pi is right here. And we have to think about sine and cosine as the x and y values of the corresponding coordinate here, which would be -1, 0. So cosine of pi corresponds with the x value. So this would be -1. So 5 times -1 is -5. And then sine of pi is the y value, which is 0. So 5 times 0 is, of course, 0. So this would correspond to the rectangular coordinate -5, 0. That's how you do it. Done. For this one, we're going to use this infographic here, and we're going to say x is equal to r times cosine of theta. The r value is the -3. Cosine of theta is pi 6. And the y coordinate is the same thing, r, except instead of cosine, we have sine, -3 times sine of pi 6. Now, if we remember on the unit circle, pi 6 is right here on that unit circle. And the coordinate on the unit circle is rad 3 over 2 comma 1/2, okay? But you can check the unit circle if you forget that. And then so now we can plug in the x value for cosine. So then the x value is -3 times rad 3 over 2. So that'd be the x coordinate. And then for the y value, it's sine of pi 6 times -3. Sine of pi 6 is the y value, which is 1/2. So -3 times 1/2 is -3/2. So that's how you do it. Done. So for this one, we're converting rectangular to polar, which is right here. And so the way we're doing it is we've got r is equal to the square root of x squared plus y squared here. That would be 4 squared plus 2 squared. And then for the theta value, we have to take arctangent of y over x, so that would be 2 over 4 or 1/2. Now we got 4 squared plus 2 squared, that's 16 plus 4, which is 20. So the square root of 20 is the same as the square root of 4 times 5, right? And you can, this is just to simplify, you can take the square root of 4, which is 2. So now I know my r value is 2 rad 5. Okay, now let's find the theta value. So arctangent of 1/2, we need to calculate that in decimals, so let's do that now. So we get 0.464 rounded to the nearest thousandth. So it'd be 0.464. That's how you do it. Done. So for this one, we're going to start by calculating r based on this part of the infographic in blue, and we're going to take the square root of x squared, which is 3 squared, which is 9, plus -5 squared, which is 25. And then for the theta value, we're going to take arctangent, right, of y over x, that's -5 over 3. Now, it does say to bear in mind what quadrant we're in. So if we think about this, this is going to be 3, -5. It's going to be in quadrant 4. So we just got to remember that when we find our theta value. So 9 plus 25, that's 34. So our r value is radical 34. Now let's take arctangent of -5/3 in decimals. And we get -1.030. And that's great because that is going to land us in the fourth quadrant. But we want something between 0 and 2 pi. We don't want a negative. So I can just find the coterminal value to this by adding 2 pi, right? And we get 5.253. So we got 5.253 for the theta. Done. For this one, we're going to convert it starting with this side of the infographic right here. So we got r is equal to the square root of x squared plus y squared. So here we got r is equal to x squared, which is 8 squared, plus y squared, which is again 8 squared. Now for the theta value, I want to tell you something because this is pretty interesting. I already know what the theta value is in a way, because if you think about 8, 8, we're going out 8 and we're going up 8. That's a perfect 45-degree angle, or in radians, pi fourths. So I know it should be pi fourths, and that should be the correct value. But we're still going to use the formula. So we would take arctangent of 8 over 8. And again, that's just 1. All right, so first, this would be 64 plus 64, which is square root of 128. And we can simplify that because that's the same as 2 times 64. Square root of 64 is 8. So my r value is 8 rad 2. Now let's calculate this in decimals. So there we go. Arctangent of 8 over 8 is that. And just to confirm what we thought, it is the same as pi fourths. That 1 value is explicitly on the unit circle. So we could have used the unit circle as well to solve for this. But anyways, we've got 8 rad 2 comma pi fourths for the theta value. That's how you do it. Done. So here we're trying to convert this equation to a polar equation. So I can still use this component from the infographic because y equals r sine theta. So this is my y value. So if we could say 4 equals r sine theta. And to get this in the correct format, we want to isolate r. So I'm going to divide both sides by sine theta. So we got r equals 4 divided by sine of theta. Now this is actually a fine response, but in the answers, what they've done is they recognize, 1 over sine of theta is the same as cosecant of theta. So we can just rewrite that as cosecant of theta in the numerator with a 4 in the front, or 4 over here, it doesn't matter, but usually we like to put the 4 in front. So that's the equation. Done. So for this one, I'm going to start by plugging in r cosine theta for x and r sine theta for y. So now we have this whole expression. So now I'm going to raise both of these to the 4th power and then multiply by 2. So then I have r sine theta equal to 2r to the 4th cosine to the 4th theta. Then I'm going to divide both sides by r, because again, we want to isolate r. That's the plan, right? So that's going to cancel out. And then r to the fourth over r is just r to the third. And I'm going to kind of flip these. So I'm going to just say 2r cubed cosine to the fourth theta is equal to sine of theta. Now all I have to do is isolate this r. So first I'm going to divide both sides by 2 cosine 4 theta on both sides like this. And the reason why is because that's going to get rid of this and that's going to get rid of this. So we're almost there. We've almost isolated r. So now we have r cubed equal to this. The last step is to take the cube root of both sides, right? So r equals the cube, because the cube root of r cubed is of course r, and that's what we want. We've got the cube root of sine theta over 2 cosine to the fourth theta. That's how you do it. Done. So since here I recognize that r equals the square root of x squared plus y squared, if I square both sides in this equation, that would mean r squared equals x squared plus y squared without a radical. So I can just simply say r squared, replace these two, equals 3x. And for x, now what I'm going to replace that with is r cosine theta. So we got r cosine theta. And then the last step is I'm going to divide both sides by r like so. And then r squared over r is just r to the first power. So now we have r equals 3 cosine theta. That's how you do it. Done. So for this one, we're going to start by substituting r cosine theta for x and r sine theta for y. So we got r cosine theta squared replacing x, r sine theta squared replacing y. And then here we've got 3 times r sine of theta. Now we're going to square all of this, and it's going to become r squared cosine squared theta minus r squared sine squared theta is equal to 3r sine theta. Now what I'm going to do here is I'm going to factor out the r squared equal to 3r sine theta. Then I am going to divide both sides by r like so, and that's going to cancel that out. Then we have 3 sine theta equal to, this r is going to cancel out with one of those r's, so now we have r cosine squared theta minus sine squared theta. And now if you remember from a double angle identity theorem, cosine squared minus sine squared is the same as cosine of 2 theta, the double angle identity. So then I can replace this with cosine 2 theta. And then the last step is I'm going to divide both sides by cosine 2 theta. And we're left with the final equation, I'm going to put it up here, of r equals 3 sine theta over cosine 2 theta. Let's put a box around it so you can see it clearly. That's how you do it. Done. For this one, we're going to plug and chug. We're going to plug this in for x, this in for y. So on the left, we have r squared cosine squared theta. On the right, we have times 9 times r sine theta. Then we're going to divide both sides by r like so. That's going to get rid of that. R squared over r is just r. So then I have r cosine squared theta equal to 9 sine theta. Last step, we're going to divide both sides by cosine squared theta. And we're left with the final answer of r equals 9 sine theta over cosine squared theta. Boom, done. So for this one, we're going to plug and chug. We're going to plug this in for x and this in for y. So I got 9r cosine theta r sine theta is equal to 1. Now we're going to combine like terms. R times r is r squared cosine theta sine theta is equal to 1. Now I'm going to isolate the r. I'm going to divide both sides by 9 cosine sine. So r squared equals 1 over 9 cosine theta sine theta. And last step, to get rid of the square, we're going to take the square root of both sides. And then we're just going to leave it like that. We're not going to bother rationalizing the denominator. I mean, we could, but honestly, they didn't in the answer, so we're going to leave it as is. So we just have the square root of 1 over 9 cosine theta sine theta. That's how you do it. Done. I'm going to start with the fact that x equals r cosine theta. And what that then means is if I divide both sides by r, I've got x over r equals cosine of theta. So first I'm going to substitute that in here for cosine of theta. So I got r equal to 4x over r. Then I'm going to multiply both sides by r, and then I have 4x equal to r squared. Now this is great because I know that r equals this, and r squared therefore equals this squared, aka just x squared plus y squared. So we got x squared plus y squared then equal to 4x. And this is one of the answers in the back of the book, so I'm going to leave it as is. But what you can do, and what they did for the alternative answer, is they put it into standard form for a circle, because this does represent a circle. But anyways, that's how you do it. Done. So for this one, the way I'm going to start is I'm going to multiply this denominator onto the left side. So then we have 6 equal to r times cosine theta plus 3 sine theta. And the reason why this is great is because then I can distribute the r like so. Then I got r cosine theta plus 3r sine theta is equal to 6. And this looks great because r cosine theta, that's x. R sine theta, that's y. So now I can replace those with x plus, again, that's y, 3y equals 6. And that's it. That's the equation of a line. That's how you do it. Done. So for this one, I'm going to start by converting cosecant to 1 over sine theta, so it's just in the denominator. Then I'm going to multiply this across to the other side, and then I get r sine theta is equal to 3. Now this is great because r sine theta right here is equal to y, so I can replace this with y, and then I've got a horizontal line of y equal to 3. That's how you do it. Done. So for this one, what I'm going to do is I'm going to start by replacing secant and cosecant with 1 over cosine, 1 over sine. So really just throwing it in the denominator like this, cosine theta, sine theta. Then what I'm going to do is I'm going to multiply this denominator over to the left side. So I got r squared cosine theta sine theta is equal to 4. Now this is cool because I can split this r up. It's 2 r's, right? It's r times r. So I can make it r cosine theta times r sine theta is equal to 4. And this is great because r sine theta is y and r cosine theta is x. So then this becomes x times y is equal to 4. And this is a hyperbola. That's how you do it. Done. For this one, we see that r is square root of x squared plus y squared. So r squared is this without the radical. So it's simply x squared plus y squared equals 4. And that's it. And this is the equation of a circle with a radius of 2, if you want to know, but it's a circle. That's how you do it. Done. So for this one, I'm going to start by multiplying the denominator to the left side. So I've got 3 is equal to r times cosine theta minus 5 sine theta. Then I'm going to distribute, and then I've got r cosine theta minus 5r sine theta is equal to 3. Now this is great because r cosine theta is x, and r sine theta is y. So I can replace those as I can say x minus 5y is equal to 3. And this is good to go. We have a nice equation of a line. That's how you do it. Done. So for this one, we're meant to find the polar coordinate of this point here. So the first thing I want to do is I want to try and figure out the theta value. So starting here, we're going around. This would be 30 degrees, 60 degrees, 90 degrees, 120. This would be 150. So this is kind of in between at 135. Now I'm talking degrees, but we're really thinking radians. So 135 is equivalent to 3 pi fourths radians, right? That's this angle here. And then how far out are we? We're 1, 2, 3, right? Count by the circles. So this would be an r value of 3, a theta value of 3 pi fourths. That's how you do it. Done. So for this one, we got to start by figuring out the theta value. So remember, we have our start here on the x-axis, and we kind of come around, boom, 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 and we go here. And look at that. We know the angle because it also tells us we're at 180 degrees or pi radians. And then the question is, what's the r value? Well, we've gone out 1, 2, 3, 4, and 5. So we got an r value of 5, a theta value of pi. That's how you do it. Done. So for this one, we're meant to plot the point. So let's start with the theta value. So we got pi thirds. Okay, so where does that fall? So this would be pi halves right here. Pi thirds is right here. And if you have a hard time remembering that, it's the same as 60 degrees, okay? Now the thing is the r value is negative. So actually it's not gonna go in this normal direction where we're starting, right? It's actually going in the opposite direction. So what I can do is I can take this and I can sort of extend this line back because we're still at that same angle. We're just going like backwards in the other direction. So now we go backwards by 2. So we go 1, 2, right? Basically 2 circles worth, and our point would be right here. So that's how you do it. Done. So for this one, we're going to start with that angle of 7 pi fourths. So starting here, we'd come around, and this is pi halves. This is pi. This is 3 pi halves, and this would be 2 pi, and 7 pi fourths is right in between these two, right? Because it's 1 3/4 pi, so we're right down the middle. And then it's a distance of 3.5, so it's like 1 circle, 2 circles, 3 circles, 4 circles in the middle of the third and the fourth. So we're saying right here. So that's how you plot it. Boom, done. So for this one, we're going to start by plotting that theta value. So again, we come out here at 0, and then we go up by pi halves. So here's pi halves, same as 90. And then on this line, we go positive 5. 1, 2, 3, 4, 5. Of course, it says 5 there, but that's how we get there, the fifth circle. So that's the point. That's how you do it. Done. So for this one, we'll start with that theta value of 5 pi 6, right? Here we'd have pi halves. Here we'd have pi. And 5 pi 6 is actually occurring right here. And then we apply the r value, which is 3. So we go 1, 2, 3 circles out. So here is your coordinate point. Done. So for this one, we're going to start with the theta value, right? And we've got here at 0. Here would be pi halves. Pi fourths is right in the middle. It's also the same as 45 degrees. But the r value is negative. So that means we're actually going to go backwards. We're not going to go out this way. We're going to go backwards. So we're going to go backwards by 2. So we go 1, 2 circles that way. There's the coordinate. That's how you do it. Done. So for this one, we're going to convert the equation from rectangular to polar. All right, so rectangular to polar, we got some good stuff here. We can plug this in for x and this in for y. So we got 5r cosine theta minus r sine theta is equal to 6. Then I'm going to factor the r out. So we got r times 5 cosine theta minus sine theta is equal to 6. Last step, we're going to divide both sides by this quantity. So we got r equal to 6 over 5 cosine theta minus sine theta. And so here's what the graph of this function looks like on the polar coordinate grid. That's how you do it. Done. For this one, what I'm going to do is I'm going to, and this is just up to me, right? This is what I feel like is going to be the easiest to do. I'm actually going to FOIL this out. So I've got x squared plus y squared minus 2y, because remember, this is y minus 1 times y minus 1. So we got negative y, that gives us the negative 2y, and then negative 1 times negative 1 is plus 1 is equal to 1. Now these are going to cancel out, and then I can say x squared plus y squared is equal to, and I'll add 2y to the other side. Now, this is great because now x squared plus y squared, since I know r is equal to the square root of x squared plus y squared, if I square both sides, I know that r squared is equal to x squared plus y squared. So I can replace this with r squared. And then I can replace the y with r sine theta. So I got 2 times r sine theta. Last step, we're going to divide both sides by r like so. And then we got 2 sine theta is equal to r. And that's what the graph looks like on the polar coordinate grid. That's how you do it. Done. So this one, we got x equal to 2, and I'm going to replace x with r cosine theta. So we got r cosine theta is equal to 2. Then we just got to isolate r. So we're going to divide both sides by cosine theta like so. Boom. And we got r equal to 2 over cosine theta. And that's what the graph looks like on the coordinate grid. That's how you do it. Done. So this one is great because we start with x squared plus y squared. And if you see right here, r squared, like if I squared both sides, r squared would equal x squared plus y squared. So I can replace this with r squared. Then I'm going to replace this x with r cosine theta. So then I got times 3r cosine theta. Then to simplify, we're going to divide both sides by r. Those are going to cancel. R squared over r is just r. So we got r equal to 3 cosine theta. And this is what the graph looks like on the coordinate grid. That's how you do it. Done. So for this one, we're going to convert it to rectangular, and we're going to do that by recognizing that r equals square root of x squared plus y squared. So I'm going to replace that with that. And then we're going to square both sides. We're going to square both sides, and we got x squared plus y squared equals 16. So there's your final equation. Let's put it in Desmos. So here we get this nice circle centered at the origin with a radius of 4. That's how you do it. Done. So for this one, I know that theta is equal to arctangent of y over x. So I'm going to replace that now. And then I want to isolate the y over x first. So I want to do that by taking the opposite of arctangent of both sides. So I'm going to take tangent of both sides, right? That's going to cancel out with that. And then tangent of pi fourths, if you remember on the unit circle, that's equal to 1. So then I have y over x is equal to 1. And then I'll just multiply across by x just to make it simpler. And we got this nice line, y is equal to x. All right, let's graph it in Desmos. There's the line, nice slope of 1. That's how you do it. Done. So for this one, I'm going to start with this. I know that r sine theta is equal to y, which also means that sine of theta is equal to y over r, right? If I divide both sides by r, which means I can plug this in for sine of theta. So now I have r is equal to negative 10 y over r. Now I'm going to multiply both sides by r to get rid of this, and then I have r squared, right? R times r is r squared equal to negative 10y. And this is great because r is the square root of x squared plus y squared, so r squared is just x squared plus y squared with no radical. And this is pretty much good to go. But what they did in the answers is they put this in standard form for a circle because this is a circle. So I'm going to show you how to do that. We're going to add 10y to both sides, and then we have to complete the square. So to complete the square, I have to take half of this value, which is kind of considered my b value, half of that, which is 5, and square it, which is 25. So I have to add that to both sides, add 25, add 25. Now I've created a perfect square here, so I can factor that. So I get x squared plus, and if I factor this, it's y plus 5 times y plus 5. That's what I mean by perfect square, because I can rewrite it as y plus 5 squared, and then this equals 25. So now you can see that this is a circle with a center at 0, negative 5, if you remember this from your coordinate geometry. But anyways, we're going to plot it in Desmos now. So there you go, 0, negative 5 is the center, radius of 5. That's how you do it. Done. So for this one, we need to find the rectangular coordinates of 2, negative pi fifths. So again, we're going to go back to these two equations. So x equals r, that's my r value, 2, times cosine of that theta value, negative pi fifths, and then y is equal to 2 times sine of that same theta value, negative pi fifths. And so we're going to plug it into Desmos now. So we get 1.618 for the x, negative 1.176 for the y. So that's how you do it. That's the rectangular coordinate. Done. So for this one, we got rectangular, we need to go to polar. So we're going to start by solving for r, which can be found by taking the square root of x squared, negative 7 squared is 49, plus y squared, 8 squared is 64. So that's equal to the square root of 113. All right, now we got to find theta, and theta is equal to arctangent of y over x. Y is 8, x is negative 7. Let's calculate that in Desmos. And this gives us a degrees value of negative 48 degrees. But here's the thing. Negative 48 is actually going to occur in this fourth quadrant, right? And we don't want it in the fourth quadrant. If you remember back to the original coordinate, negative 7, 8 is actually in the second quadrant. So what we need is we need the same value, but in the second quadrant, same reference angle, basically. So to get that, we can take this value and we add 180 to it. That puts us in the second quadrant with the exact same reference angle. So now we have 131.186. And then for square root of 113, we get 10.630. So we got 10.630, the r value first, and then the degrees value. We've been doing radians, but now we're in degrees, 131.186 degrees. That's how you do it. Done. So here we're going to get the polar coordinates of these rectangular coordinates in radians. So again, r is equal to the square root of x squared plus y squared. So x squared, negative 2 squared is 4, y squared is 0, because 0 squared is 0. So we get r is equal to the square root of 4, which means r is equal to 2. And then to get the theta value, we need to take arctangent of y, which is 0 over x. And again, that's just 0, right? So we need to take arctangent of 0. So arctangent of 0 is 0. That's 0 radians. So we might say 2, 0. But here's the thing. 0 radians would mean we're right here and we're out 2. But this original point, remember, was at negative 2, 0, which is out here. So what does that mean? That means that we have to get the other direction. So it's not 0, actually. An arctangent of 0 is actually going to be another angle on the left side of the x-axis, right? Same reference angle, which would actually be pi. So we can say 2 pi, that's the coordinate. So for this one, it says describe the graph of r equals a secant theta, where a is negative. So let's plug this into Desmos and let's look at it. So there we go. There's the graph, and it just looks like a vertical line. And for this one, when I made a negative 2, it looks like it's 2 units to the left. Let's make it negative 3. Now we go 3 units to the left. How about 6? 6 units to the left. So that's how it's affected. That's how you can describe it. Done. It says describe the graph of r equals a cosecant of theta when a is negative. So let's plug that into Desmos now. So here we're starting with negative 2 for a, and we get a horizontal line 2 units down. What if we change that to negative 3? Now it's 3 units down. So that kind of affects the distance it drops down. But anyways, it's a horizontal line. Done. So for this one, it says to graph r is less than 4. So I'm going to show you what it looks like in Desmos and explain it there. So when you look at the graph, this is, r is basically the radius, how far out, right? So when it's 1, you're a radius of 1 out, 2, you're a radius of 2 out, etc., right? So r is less than 4. That's going a radius of 4 out. So it would be all the values that are less than this circle with a radius of 4. So now you can see what that looks like. R is less than 4. And again, notice it's dotted because it's not less than or equal to, it's less than. But that's basically it. It's a filled in circle, done. So for this one, we got theta is equal to pi fourths, and it's saying r is greater than or equal to 2. So again, r refers to like how many circles out we are, the radius, right, from the center. So 1, 2. So r is greater than or equal to 2. So it's greater than or equal to this. But then we're given a set angle of pi fourths. Where does pi fourths occur? Pi fourths is basically like 45 degrees. It's right down the middle. So it's down here like this. And then I could say it's like this line, right? If theta equals pi fourths, it's this line, but only when r is greater than or equal to 2. So starting here would be the line, and then it's going to go in this direction. So that's how you graph it, done. So for this one, I'm going to plot it in Desmos, and then I'm going to explain the components. So first we're starting out with just r is less than 2, right? So that's again a radius of 2 and then going all the way around. So it's that entire circle with a radius of 2 filled in with a dotted line because it's a less than, not less than or equal to. But now let's put in the theta restrictions. So they want this to exist only from 0, which is right here on the x-axis. Let's zoom in. And then up to pi thirds, which is going to be up here. It's like 60 degrees. So it's going to be a little slice of pizza. So 0 and pi thirds. And then there it is, right? From 0 to pi thirds. And we got that little wedge, done. I hope you guys enjoyed this video. And if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.